Hello, class, and welcome to part 2 of the Unit 4 review. So here we are on question number 6. The relative frequency histogram represents the length of phone calls made on George's cell phone during the month of September. We want to determine if the histogram indicates a normal distribution, could model the variable. And we could see, based on this particular graph, we don't know the exact number of these, but that definitely does not look bell-shaped. It's a skewed right distribution. So, because of that, this is going to be a no. The histogram is skewed right. It must be bell-shaped. To be modeled by a normal distribution. Question number 7. This is where here we have the graph of the normal curve given. We want to find the value of the mean and the standard deviation. So for this, the mean, directly in the middle, is 530. And to find the standard deviation, we are looking at the one standard deviation below and the one standard deviation above. We add 2 to get from 530 to get 532, and subtract 2 from 530 to get 528. So the standard deviation for this will be the value of 2. Question number 8. The lengths of human pregnancies are normally distributed with a mean of 266 days and standard deviation of 16 days. The area to the left of x is equal to 245 and the right figure is 0.0947. What does this mean? And then what does the area to the right of x is equal to 245 mean? So for this, this is going to be the proportion. Or probability. Those could be used interchangeably. Of pregnancies that are less than 245 days. Is 0.0947. So the area to the right of x is equal to 245 is the proportion. Again, or probability. A pregnancy lasts for more than 245 days is 0.9053. And let me just fix that 9. 0.9053 in this case. No calculation was needed for that, other than doing 1 minus 0.0947. Question number 9. I want to assume the random variable x is normally distributed with a mean of 50, standard deviation of 7. We want a whole bunch of things, as you can see on this, right? We want here for part A, probability of random variable x is greater than 39. We want the probability of random variable x is between the values of 44 and 51. We want the 78th percentile. So that's the probability of random variable is less than or equal to some number, x sub 1, is equal to 0.78. And then finally, we want to know is the value of x is less than 30, unusual. So we need to find that as well. Okay. Let me pop these into StatCrunch. And then we'll do each one first, and then eventually put it back into our document. So we're going to stat calculators, normal. Stat calculators, normal, for us to get this value. These values, I should say. Oh, for part A, this had a mean of 50, standard deviation of, in our case, 7. We want the probability of greater than 39. And according to this, that's 0.94196 in this case. Part B wants the value between 44 and 51. So I'm going to select the between option and then put 44 and 51 in. And doing so gives us a value of 0.36112. The 70th percentile, I have to go back to the standard one. This will change here to be a less than or equal to. And we put in 0.78 into the box to the right of the equal sign. Doing so indicates that the 70th percentile is 55.41. And then finally, we want to know if the probability of x less than 30 is unusual. Putting in 30 and not changing the inequality symbol gives us a value of 0.0021. So let us write all these down based on the numbers that we just received. So probability of x greater than 39, 0.94196. Probability of being between 44 and 51, 0.36112. The 70th percentile, x sub 1, is the value of 55.41. For the probability of x being less than 30, that was 0.0021. And for that matter, the 0021 is indeed a small number, right? This is less than 5%. So yes, this is unusual. For that matter, the usual observations for this one within the 2 standard deviations would be between 36 and 94. 36 and 64. 30 is less than that. So that would also be a way to determine the unusual-ishness. And then the last one for this part. We want the value of z sub 0.25. So this is the probability we have a z-score greater than or equal to some number x is equal to 0.25. The picture that corresponds to this with a mean of 0. We have x to be down here-ish, and we want this area above it to be 25%. So, putting this into StatCrunch, since this is referencing a z-score, this uses a mean of 0, a standard deviation of 1. This needs to change to be a greater than symbol, and we need to put 0.25 into the box on the right of the equal sign. Doing so gives us a z-score rounded to 2 decimal places as 0.67. So x will be 0.67 for this question. That's part 2 of this Unit 4 review. Let me know if you have any questions or concerns, and good luck on the test. Thank you.